Good morning, Year 4. It's Mrs. Dunn here, and it's Wednesday, the 13th of January. On the board to start us off are our mental maths questions. Have a look at each question and write down the answer, and then come back to me and we'll go through each one and share the answers. Pause the video now and have a go at each of those questions. Okay, so on the board now we've got the answers to each of the questions you've just completed. Question number 1, we've got James is 9. How old will he be in 8 years' time? And 9 add 8 is 17, so James will be 17 years old. What number must be added to 8 to make 20? 8 add 12 equals 20. How many 10p's are in 80p? So if I count up in tens, 10, 20, 30, 40, 50, 60, 70, 80, I need 8 10p's. Tom has 12p. He gave a quarter of his money to Emma. How much did he give her? And the answer is 3p, because 12 divided by 4 equals 3. How many sides does a pentagon have? And the answer is 5. Write down the even numbers between 3 and 9. So you should have written down 4, 6 and 8. One piece of string is 4 centimetres long. How long would 9 pieces of string be? And the answer is 36 centimetres. Question 8. What is 8 times 6? And the answer is 48. Number 9. It is 9:15 a.m. What time will it be in 3 hours? And the answer is 12:15. What is the total of 5p, add 6p, add 5p? And the answer is 16p. Well done. Hope you've ticked the ones you got correct. Let's have a look at today's maths lesson. So today we're going to be partitioning numbers, and my vocab lab today, these are some of the words that we're going to be looking at. Thousands, hundreds, tens and ones. So we're going to be looking at how many thousands a number has, how many hundreds, tens and ones it has. We're going to be partitioning, so we're going to be breaking that number down into thousands, hundreds, tens and ones. We're looking at the value of each digit. We're looking at figures. The value, because we're looking at place value, so we're thinking about how much each digit is worth. And then recombining is where a number has been partitioned and you might have to put it back together. Let's have a look at our first question. So if I am partitioning this number, I'm thinking about the value of the tens number and the value of the ones number. So 53 would be partitioned into 50 and 3. And that's the sort of thing we're going to be doing today. So I'm breaking the number down into different amounts, and I'm using a 0 to show the real value. So I'm not going to just say that this is 5, because this 5 here is actually the value of 50. So it's really important today that we use those zeros. Let's have a little look at a video. To copy that video into Sorry about this, children. So if I copy, okay, so this is the video that I want us to have a look at.
Partitioning is a useful way of breaking big numbers up into smaller pieces, so they're easier to work with. Isn't that right, guys? Take the number 23. Let's break it down. Not like that. Like this. You could think of 23 as one big 20 and a little 3. Or how about we split that another way? Into a 10 and a 13. Together they also make 23. We can break up even bigger numbers too, like, say, 746. Incoming! And look at what we have. One big 700, 140, and a 6. 746. Partitioning means you can split numbers apart, like into ones, tens, and even hundreds. This breaks down big numbers when adding and subtracting and doing other fiddly maths problems. Oh, guys, time to split.
Okay, so we saw in that video how a 3-digit number can be split into hundreds, tens and ones. So on the board you can see this number here. What number is that, children? Well done, it's 736. So if I was to partition 736, I'm going to start with my hundreds, and I'm going to say that that hundreds column is 700. My 3 tens represent 30, and my 6 ones. 736. Let's have a look at another one. So this time I've got a 4-digit number, so I'm thinking about my 3000. The number altogether is 3152. So my 3 is representing 3000. My 1 is my 100. My 5 is worth 50. And my 2 ones is just a 2 on its own. So 3152. Okay, have a look on the board now, children. I've got some numbers and then I've partitioned them underneath. Pause the video and just match up each partitioned number to the number I started with. Pause the video now and then come back to me. Okay, so on the board now you can see the correct answer. So 12 is partitioned into 10, 1 and 1. 40 could be partitioned into 40 and 1. 24 into 10, 10 and 4, and 36 into 30 and 6. Some of those were a bit trickier because it was partitioned in different ways. Let me show you how to do that. So before we do that, we'll just have a look at recombining. So 2343. If I say the number and write down 1 digit to represent that number, it helps me to recombine. So instead of writing 2000 with the zeros, I just write 1 digit to represent that number. 343. So you can see there how I've got my 2000, my 300s, my 40 and my 3. Okay, so like we saw in the video, sometimes numbers can be partitioned in different ways. So I've partitioned 57. 50 add 7 is 57. But I could also partition into 10, a 10, a 10, a 10 and a 10, and 7 ones would also give me 57. Have a go for year 4, pause the video and write down another way that 57 could be partitioned. Pause the video now and then come back to me. Okay, so you might have written 10, add 10, add 30, add 7 equals 57. There are lots and lots of different ways. What you need to make sure though is that whichever numbers you have written, they always total the number you are partitioning. So the numbers you've written down now must total 57. Okay, on the board now you've got some fluency. Also uploaded into the Teams folder for today is a scaffold. If you think you're going to find this a bit tricky, there's a sheet with some easier numbers on for you to begin and have a practice with. So to start with, if you are doing this fluency, you're partitioning these numbers, and then here you're recombining the numbers. So you're writing down the number that I started with. Pause the video and have a go at those, and then come back to me and we'll go through the answers. Okay, so here are the answers. So 72 would be partitioned into 70 and 2. Give yourself a tick if you got that correct. 159 would be partitioned into 100, add 50, add 9. 596 would be partitioned into 590 and a 6. 1326 would be partitioned into 1320 and 6. 5693 would be partitioned into 5690 and 3. If we're recombining, it means we're putting the numbers back together. So 50 and 6 would become 56. 140 and 2 would become 142. 1342 would become 1342. 2430 and 0 would be 2430. And then finally, 3000 add 100 add 20 add 1 would give you 3121. See how you got on with those Year 4. Give yourself a tick for each one you got right. If you need to rewind the video and practice again, then you can. Let's have a look at what we're doing next. So what we're going to do now is look at how we can partition in different ways. So on the board you can see I've got 42, and I've easily partitioned that into 40 add 2. But I can also partition it into 30 add 12. I'm going to show you now that I could also partition that number into 20 add 22. That would still give me 44. I could also partition that number into 10 add 10 add 20 add 2, and again that would still give me 42. Okay, so it's the same number but I've just partitioned in different ways. Still totals 42. Let's have a look at another one. So this time I've got 57. So we've partitioned the 57 into 50 and 7. But I can also partition that number into 40 plus 10 plus 7. I could also partition it into 30 add 20 add 7. I could also partition it into 30 add 27. So I'm just manipulating the different numbers that I've used already. And I could also say that it's 20 add 37. So you can see there, each of these have been partitioned from 57, but just in different ways. On the next slide, there's going to be one for you to try. So have a go at 68. So you're finding 5 different ways of partitioning 68. Pause the video now and then come back to me when you've had a go. Okay, you should have had a go at partitioning 68. Remember, there are lots and lots of different ways. I'll show you the 5 that I've thought of. So straight away I'm going to do the really simple one of 60 add 8. Then I'm going to think that actually I might have 50 add 10 add 8. I might also have 50 add 18. I might have 10 add 10, add 10, add 10, add 10, add, so 10, 20, 30, 40, 50, add 18 would give me 68 as well. And I might have 40, add 28 would also give me 68. So as long as the methods you've used, the calculations you've used equal 68, you should be on the right lines. Let's have a look what else there is. So we've got some problem solving here. So what I'd like you to do is think about the number that's being represented and then find 3 other ways to partition this number. Remember that the total still has to remain the same. Okay, can't take any away or add any, you're just moving the counters to make different ways. Pause the video and come back to me when you're done. Okay, so now we're on to some reasoning. So Jack says my number has 5,364 ones. Amir says my number has 53 hundreds, 6 tens and 4 ones. Who has the largest number? Explain. Remember, when we're reasoning, it's really important that you explain your ideas clearly. So pause the video and then come back to me when you're ready. Okay, so here's the answer to our reasoning question. So actually, both Jack and Amir have exactly the same number. They've just partitioned in different ways. So if we have a look at the number that Jack's made, go back onto my pen. So Jack's number has 5 thousands. So there are my 5 thousands for Jack. 300s, there's my 300s, and 64 ones. So if I write my 64 ones, there is Jack's number. Now let me write Amir's number. 53 hundreds. So here's my 53. 6 tens. So I'm just writing down the numbers that they've said. And 4 ones. And if I put my comma after my thousands, can you see, children, that those numbers are actually exactly the same? Both of those numbers are 5,364. If you just write down the numbers that they say, it shows you that they're the same. Okay, also uploaded into the folder today are the stretch challenges. If you are feeling very stretchy today, you can have a go at those. Also uploaded are the answers to those stretch challenges. Okay, so that's the end of our maths lesson for today. So today we were partitioning numbers. Hopefully you've marked your work as you've been going through the video, or if you've had a go at the scaffold or the stretch, you've managed to look at the answers to your work on the screen. Hopefully you've done okay. If you haven't, remember to join us at one of the live sessions or drop me an email and we can have a look together. Tomorrow we're going to be ordering and comparing numbers. Thank you for listening, Year 4. Speak to you tomorrow. Bye.